This is the Minecraft Speedrun World Record. 7:01, a seemingly unbeatable run. Or was it? When I was watching this record, a thought popped into my head. What if we could create an AI to beat the Minecraft Speedrun World Record? So, I did some research to see if this has even been done before, and this was it. 3 hours and 8 minutes. The fastest and only time Minecraft has ever been beaten by AI. In this run, they used an AI called Baritone, which is able to pathfind its way into completing different tasks until it has eventually beat the Ender Dragon. But the AI dies multiple times throughout the run, it doesn't use any speedrun strategies, and actually doesn't even know how to play the game. Even tech giants like Nvidia and OpenAI haven't been able to create something to beat the game. Nobody had done this, so I wanted to be the first. But it seemed like all hope was lost. Until one day, July 30th, 2024. A video uploaded by the user Calvin showcases an improved version of the exact same bot beating the game in 31 minutes and 4 seconds. 6 times faster than the previous record. I checked out the video, and this version of the bot is a drastic improvement from the last one. It doesn't die once and is even able to one-cycle the dragon. And I started to think, this may actually be possible. But wait a second. This isn't actually an AI. Although it might look like an AI is playing the game, it's actually not. What you're seeing is a combination of Baritone's very complex pathfinding algorithm and autoclef, made by Taco Technica, the original bot speedrunner, which breaks down larger tasks into smaller ones for the bot to complete. So what is the actual difference between an AI and a bot? Well, an AI is able to respond and adapt to new situations that it hasn't been programmed to respond to. For example, if you ask ChatGPT to do something highly specific, it can still generate a helpful response, even if it wasn't explicitly trained to do so. Whereas a bot has every action hard-coded. A good example of this is Siri, which may seem like an AI at first, but all it is responses extracted from a huge database and not reasoned to fit the user. The same applies here. On the GitHub repository, we can see the entire process of beating the game, coded in over 2,000 lines. And because of this, when I tested it, every single time it would follow the exact same steps, with the only way to improve its performance is just by using a better seed. By this point, I was ready to give up, as even with thousands of lines of code, there was no way for the bot, let alone an AI, to break the record. It felt as if my dream was slipping away into the abyss, and I had lost. Just as I was ready to accept defeat, I came across a post on X showcasing Nvidia's Voyager. A mix between GPT-4 and hard-coded instructions. It was exactly what I had been looking for. I just had to see if it could beat the game, and at first glance, it was not looking good. In the demo and when I tried it out myself. It seemed confused and couldn't really understand the game at all. Oh, he's going! Oh, shit! Go get him, you stupid dumbass. Oh, he's stupid as... Yeah, he's an idiot. Nah, this dude's gotta be trolling, bro. Let's see if he actually gets wood. Come on. No, this way. This way, you freaking idiot. This? Oh, you're dead. Oh, you're so stupid. But why is that? Why is the performance so bad even though it's powered by GPT-4? Well, let me show you how it works. It starts by following a pre-coded curriculum that sends it through the regular Minecraft steps, like mining wood, making a crafting table, and so on. But when it encounters something new, such as a zombie, instead of following the pre-coded rules, it uses GPT-4 to reason and code a response to deal with the new circumstance. Lastly, it adds that to a skill library so it can use it at a later time. Since the whole thing was, at its core, a skill library that the AI retrieves from, it would make it a whole lot easier to implement in code if every task and outcome needed to complete a speedrun was fully mapped out. So that's exactly what I did. I spent a ridiculous amount of time mapping out every single aspect of speedrunning Minecraft. And when I say every aspect, I mean every aspect. What items to look for, how to handle different biomes, even the exact routes to run in a bastion. Yeah, I didn't even know this was a thing, but there are pre-made routes that guarantee the fastest time in all 4 types of bastions. Thanks to RecRap, I watched your 3 videos over and over until I had this. I mapped out basically the entire game and all the strategies needed to speedrun Minecraft in the fastest way possible. Yeah, this took a while. It's incredibly complicated. Once I had this roadmap, it made it a lot easier to know what to actually code. But even if I was able to code skills for every one of these outcomes, there was still one problem. The AI can't see. And I literally mean this. The current Voyager only knows what's going on because it uses a package called the MindFlayer that provides it structured text data about the player and what's around it, including the health bar, hunger, what biome the player is in, and blocks that are nearby. While GPT-4 is incredibly smart, only knowing what's going on just from text is a huge limitation. For example, what if 40 blocks away there was a village, but since MindFlayer only returns what's nearby to avoid being overloaded, it would quite literally run right past it. We can also see it being a limitation with autoclef and baritone, where in my testing, it was trying to get flint, and literally right in front of it, there's flint, right there. But because it didn't go directly into its inventory, it didn't even know it was there. I wanted to see if I could fix this problem by implementing vision into Voyager. So I started by fine-tuning Gemini 1.5 to actually output useful data that GPT-4o could utilize. Yes, I upgraded to the better model. I created this vision assistant that takes images from Minecraft just like here, and now to output this information so I can better get what's happening in the world. Once I had it working, it was time to implement it into the Voyager codebase using a package called Prismarine Viewer, which allows you to get a first-person view of what the bot sees. And after many hours of error after error after error, oh, why would you do that, you idiot? I realized something. In the FAQ on Voyager, they talk about using Prismarine Viewer, but say they didn't because the quality wasn't good enough. And after my testing, I found out what they meant by that. Look at how trash this looks. This looks like Minecraft off the dollar stores. Oh my god, look at how high poly I am. While Voyager is a step in the right direction by combining pre-coded instructions with an AI brain, that is GPT-4, at this point in time, it just simply won't work. But there's still one more method that could be used: video pre-training. OpenAI's approach to making an AI bot is a lot different from anything else we've seen. In their project, they take a small video dataset labeled with keyboard actions and train a model called an IDM on it. They then use that on a way larger dataset of unlabeled videos to get their keyboard actions, and then the AI is able to replicate tasks with all the information it's learned. And now I had my answer. Between all of these methods, from baritone and autoclef to video pre-training and Voyager, could we actually beat the world record? Well, yes, but actually no. In theory, it is possible, but I can't do it alone. So here's how you beat the Minecraft world record with AI. First, you need to code autoclef and baritone to beat the record themselves and consistently get top of the leaderboard times. You can do this by coding each step in the exact speedrunner guide I made and fixing all the places where it's inefficient. Then, you record hours of the bot beating the game, along with something that records the keyboard inputs, until you eventually have a small dataset of labeled video data. Then, you can use the OpenAI keyboard prediction model to label hundreds of top competing runs on speedrun.com. After that, you train the model using the data while also incorporating real-time vision. Next, utilize reinforcement learning and hard coding skill implementation to refine the model's ability to perform complex tasks, like building the nether portal and calculating the stronghold position with one throw. Finally, you run the model on thousands of Minecraft worlds, specifically on 1.16.1, refining each and every time if it underperforms. And that's how we can theoretically beat the Minecraft speedrun world record with AI.